Hi, today we're going to be looking at the most common quadrilateral that we have, and that is a parallelogram. I'm going to walk you through some of the basic properties of a parallelogram, and you'll be using these properties to solve the questions along the way. If you need to pause the video at any time, please do so that you can have a chance to write down the properties, because again, you'll use them along the way in this unit. All right, so let's get started. Again, we're going to be looking at the properties used to solve. So to start with, we're going to talk about the sides. All right, so a couple important things that you should know. Opposite sides are equal. And if you'll notice how the tick marks are starting to show up, that means that the top is equal to the bottom and that the right is equal to the left. Now, it should be noted that the left and the right sides are not equal to the top and the bottom sides. That's the reason that you have double tick marks on the top and bottom and single tick marks on each side. Okay, the other thing that we should know about the sides is that I have two pair of parallel sides. The left and right are parallel to one another, and the top and bottom are parallel to one another. Okay, the next thing we want to look at then are the angles. All right, opposite angles are equal. And really it should say opposite diagonal angles are equal. You'll notice in the picture here, this green is equal to this one, and this red is equal to this one. So opposite diagonal angles are equal to one another. Now, you'll also notice consecutive angles are supplementary. So consecutive simply means one angle right after the other. So this green and this red are consecutive. And that's true of the angles all the way around. Supplementary just means that they add up to 180. So when I go to use these to solve, I can say the bottom left and the top left. I can add them together and set them equal to 180. All right, so then the last property that we want to look at has to do with the diagonals. A diagonal is simply a line that I draw from one vertex to the opposite diagonal vertex. And if you'll notice, my diagonals are going to bisect each other. However, they are not equal to one another. Okay, so when I go to set up a problem with the diagonals, I can say that this side is equal to this one. I can say that this side is equal to this one. But this diagonal right here is not equal to this diagonal right here. All right, we do have to solve for them separately. All right, so let's look at the type of problem that you're going to be dealing with. Here's a parallelogram labeled J, K, L, and M. And I have a lot of information that's given to me in the picture, but if you'll notice, my question here says, solve for x. So that's all I'm looking for. Here's an x, and here's an x. Okay, so that tells me that I'm dealing with the sides. And since our opposite sides are equal to one another, I'm simply going to set my expressions equal to one another. And that's going to give me 7x is equal to 3x plus 14. That's probably the most important part of your problem right there, is just getting it set up correctly, because now all we have to do is use our algebra skills to solve. So I'm going to subtract 3x from both sides. This is going to leave me with 4x is equal to 14. And at this point, I'm simply going to divide both sides by 4. And when I do, I get x is equal to 2.5.